So for number 35, we're taking the area bounded between these two curves, and we're revolving about the line x is equal to pi over 2. So it's telling us to consider the area between 0 to pi, which is until from this point here until that point. However, when we rotate it, when we take this section over here, maybe I'm going to do that in a different color. When we take this section over here and we rotate it about that line, and then we take the other side and we also rotate it, that is going to overlap because these areas are symmetric, right? So since they're going to overlap, it doesn't make sense to integrate both of them, because integrating both of them is the same thing as integrating one because of that overlap. So what we're going to do here is we're just going to integrate it from 0 all the way out to pi over 2. That's because that's an easier bound of integration. But if you would like, you can integrate from 0 to pi, and it turns out to be the same thing. So our volume is going to be defined from 0 to pi over 2. Okay, and so when we rotate this, we're going to take this section here, and now this line is the difference between these two curves, right? It's the distance of the red curve, which is sine squared, minus the distance of the blue curve. So if I go the red minus blue, I'm left with just that little chunk. So I'm going to take this little chunk, oops, I'm going to take this little chunk here, and I'm going to revolve it about the line x is equal to pi over 2. And so when I take this chunk and I revolve it, it is going to give me an area, right? If I think about unwrapping the cylinder as though it were an infinitely thin sheet of paper that got wrapped about that line. So this is going to have an area, and it is going to have an area as a function of x, because if I move along further across the x-axis, we can see here that it's going to be a very tiny cylinder, right? So these cylinders definitely do change as a function of x. And so my volume is going to be the sum of all these areas of x, since the integral is a sum, and then if I sum up a bunch of areas, I'm going to get a volume. So all we have to do now here is we have to figure out how to express this this area in terms of x, right? So what I'm going to do here is, first this area, well, this area has base times height, and this area here, the height is just that little difference, as we've said, right? So we've previously discussed the fact that this is just the red curve minus the blue curve. So this one's going to go sine squared of x minus sine to the 4th power of x, because that's the height of the red minus the height of the blue. Okay, so we've established the height, and now we have to establish the base, right? This base here. And as we can see, the base is just the base of the cylinder. Now, any cylinder has the base, a circumference, right, of 2 pi r, because it's just a circle here. And so our mission is to describe our radius in terms of x, because we're integrating with respect to x. So it looks like this point is maybe let's say 0.8, right? This is just a rough estimation. We can see here that the radius goes from pi, I'm going to do that in a different color actually. The radius goes from pi over 2 all the way out to 0.8. However, this distance is not 0.8, right? Even though that coordinate is, because this radius in blue is going to be pi over 2 minus 0.8. And so if we calculate that, let's see, that's 1.57 minus 0.8. This gives us roughly 0.77, which is not the same thing as 0.8. The reason that it's not the same thing is because the distance 0.8 is measured out from 0, right? Is measured out from 0 all the way out to here. So actually, this blue curve is the whole length of pi over 2 minus that green arrow. So the radius really is going to be pi over 2, that whole distance, minus x. In this case, our x was 0.8, right? But in case, and just to make this very clear, suppose that I was revolving this area right here. that is really, really close. Maybe it's at 1.25, right? If I revolve it, this radius is not going to be 1.25 because 1.25 is measured from here all the way out to there. This radius here, this length, is going to be pi over 2, so 1.57 minus 1.25 to give us that little tiny chunk. So to reiterate, our radius is going to be pi over 2 minus x. So let me remove all of this. So once I have an expression for the radius, I can just here now, I have my base, right? Because the base is 2 pi r, so 2 pi times pi over 2 minus x. And this comes from that idea of the circumference. So once we have this, we are ready to get an expression for the area, right? So area is equal to base times height is equal to, the base is 2 pi times pi over 2 minus x times the height, which is sine squared of x minus sine to the 4th of x. And so once I have this, this is equivalent to my area, right? So all I have to do now is sum up my area. And so I'm going to just put that in my integral. I'm going to move that to my integral. And then there's a little dx at the end because we're summing them up across the x-axis. So once I have this, it's asking us to use a computer algebra system to find the exact volume. So we don't have to integrate it by hand, we can just put it in a calculator. And so I'm using the online calculator Symbolab. So when I plug this integral into Symbolab, I'm going to evaluate it from 0 to pi over 2, and this gives me a volume of pi cubed over 32. And so that's what I get when I take this area here and then I revolve it about the line x is equal to pi over 2.